Hi students. All right, so we're starting chapter 7, lesson 2, climate cycles. So there are long-term cycles and short-term cycles. So long-term cycles are events that last thousands, if not millions of years. All right, so examples of long-term cycles would be the ice ages. They're believed to have began about 2 million years ago. And then there's a time in between ice ages that are warm periods. So you might have an ice age, then it warms, and then you have another ice age. And so those times in between ice ages are called interglacials. So there are patterns of these big events happening on Earth. All right, and we're currently in an interglacial. We're in a warming period between ice ages. And the one we're in is called the Holocene epoch. Holocene, and then the next word epoch. So we're in an interglacial, a warming period between ice ages currently. All right, so some of the things that create long-term and short-term cycles. First of all, we know that there have been long-term cycles because we can look at natural records. We can look at the growth rings of trees. You know that we have trees that are hundreds of years old, and we can see what was going on in the climate and that particular region during those times. There's fossilized pollen captured in snow, like in the Arctic and Antarctic. And then ocean sediment tells us information as well, because those layers get layered on top, just like our sediment on Earth gets layered. Okay, so they use all that information. They can even measure the CO2. They use all that information to compare it to the current climates, to see what used to be going on and what levels were, and the health of Earth and the temperatures of Earth. So by using those things. So some things that cause these long-term cycles. First of all, the shape of our orbit. If we had a circular orbit, and I know that the sun doesn't orbit the Earth orbits the sun. But I just kind of want to show you an example of what, if you had a circular orbit, see my apple of science. If you had a circular orbit, it would always be the same distance from what it's orbiting. So if this were the sun and this were the Earth, it would always be the same distance, okay? So there wouldn't really be as drastic a seasons because ours is not circular. Ours is elongated. Our orbit is elongated. So if this was the sun, Earth is doing things like this, and then coming back closer, and then going around, and then coming out really long, going in a little closer. So that plays a role in our seasons as well. Of course, Earth's tilt is very important about the seasons. So when we talk about the seasons, we're talking about short-term cycles. And matter of fact, tomorrow, September 22nd, is the first day of fall. It's the autumnal equinox. Equinox means equal day and night. Equinox, equal day, equal night. So on that day, you'll have the closest to 12 hours of sunlight and 12 hours of night. Okay, equal day, equal night, equinox. So there's two each year. There's the autumnal for autumn, and there's the vernal for spring, which goes into summer. Okay, which is the leading point going into the summer. All right, so why did those happen? Remember, Earth has a tilt. Okay, so here's our tilt. When Earth is, we call it flat side. When this is now my sun source, you see the light source, that's going to be my sun. So when Earth's tilt is flat faced here, the tilt is not towards it or away from it, it's flat faced, that's going to be one of your equinoxes, because as the earth spins, do you see how it's getting equal day, equal night? It's either getting light or not getting light. Equal day, equal night, equinox. The tilt is not affecting it. Here we are. We're right in here. Okay, that's us. Equal day, night, back to day. All right? There's the other one. Flat side, equinox. Now, when the northern hemisphere is pointed towards the sun, the tilt is pointing towards the sun. Notice how there's less light down here and more light up here. This is going to be our summer, because we're going to have, look at all this space that's getting light. There's just this little strip back here, just this little strip back here that's getting no light. That's the nighttime. So this is our summer. We have long days, short nights in the summer because of the tilt of Earth, the northern hemisphere being tilted towards the sun, right? When we're tilted away from the sun, notice we're not getting a whole lot of sun up here in the northern hemisphere. This is winter, okay? This is our winter. This is where we're headed. So we're right now, tomorrow is an equinox, and it's going to slowly but surely, as it moves around the sun, it's going to slowly but surely move away. And then in December, we will have our winter solstice. That'll be the shortest day, because we'll have very little sunlight hours and more nighttime hours. That's why we get up in the dark and get home in the dark in the winter, because we're pointed away from the sun. Okay, so the tilt of Earth, the tilt of our axis, is part of the reason for seasons. All right, and then our orbit is another reason. It is not a circular orbit. It is an elongated oval. Okay. You guys learned about El Nino from the Bill Nye video. El Nino. You're going to read about monsoons, and you need to understand monsoons. The rainy season happens. Remember, we learned about high pressure and low pressure. The high pressure is over the colder, so the water is going to be colder. So it has the high pressure over the water. Air always wants to move from high to low pressure. So we're moving that air mass that formed over water. What do we know about that? It's going to be humid. It's going to be carrying water vapor. So that air mass is going to move inland. It's carrying all that humidity with it, all that water vapor with it. It's going to hit the low mass. What do we know about happening with cold fronts? Cold air colliding with warm air? Rain. And if it becomes stationary, which is usually what ends up happening, heavy, heavy, heavy rain for long periods of time. Monsoon season. Okay? In the winter, the land is actually colder than the water because of the specific heat of water. So we're putting all these things together, all these pieces I've been working with. The land is going to be colder, so it's going to have the high pressure. So it's going to move from land. What is the air mass over land? Dry. So it's going to move, that air mass is going to move towards the water. Okay? No heavy rains. But when it moves from the water, high pressure, because the water's colder than the land, it's going to carry water vapor with it, and you're going to have heavy rains on the land when it reaches the land. Okay? It's going to form those clouds. It's going to be stationary fronts. And just rain, 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 rain. Okay? Or even cold fronts sometimes too, real violent, quick storms. All right. We also have things called heat waves. Periods of unusually high temperatures. And then we had cold waves. We really do have things called cold waves. Periods of unusually cold temperatures. And then we do have things called drought, when we don't get enough precipitation, where we have long periods without rainfall, is a drought. All right, you're going to read and take notes over Chapter 7, Lesson 2. And the guided readings I'm pushing out, you need to use those, but you're not going to write on those. You're going to get out a piece of paper, and you are going to copy the guided reading, filling in the blanks that are needed to fill in. So you'll write climate cycles, capital A, so you're basically going to be doing an outline format. Long-term cycles, and then you'll space in, you'll write number 1. And I'll give you the first one. A long-term climate cycle takes much longer than a lifetime to complete. So you're writing that whole thing, and then you indent a little and you break that down. A, to learn about long-term climate cycles, scientists study natural records, You're writing it all down. You're not just writing the answer for the blank, you're writing it all down. These are your notes for this lesson. Understood? All right. Have a good day.